Hello, thank you very much for joining today this venue. My name is Spiros and I'm going to present to you information about the 5G networks and how the 5G networks they will be useful for a smooth migration to mobile operators. This is a very interesting story because you see mobile networks they are facing a transformation. So yeah, lovely, thank you. So we are in a point, if you can see the slide, where before that point there was the installation part, which means that most of the people or most of the mobile operators were trying to build new infrastructure into the game. And after that, in that point and in the future, we are facing a transformation, meaning that we have to be able to provide services, high throughput, high fast internet, and as well as IoT devices, millions of them over the network. And believe it or not, the networks nowadays, they are not ready to fulfill these conditions. Actually, we can't provide all this type of information over the networks. So you can see on the slide, we have actually moving from the 5G, from the 4G up to the 5G, there is a tremendous increase on the bandwidth that is needed, and at the same time we have to have a very small latency in order to be able to have real-time services, IoT services. Okay, so what is expected is, as I told you, more connections are coming through. And if you ask me the question, where are the connections coming from? The answer is, of course, is not from the people, because the people is finite in the planet, but what is infinite, looks to be infinite, is actually the IoT devices. So IoT devices, there will be billions of them in the near future, and we will have to be able to accommodate all these type of connections. And that's why you see this tremendous increment over the slide, over the graph. And all this tremendous increment means actually that we have to have something like 50 billion connected devices. So it's the devices era that has to be accommodated over the mobile networks. Of course, operators, they have to have some opportunities coming through. If you see that graph, you see that we can have opportunities coming from connected cars and media partnerships. We have small, smart applications, smart cities. We have also mobile banking, like the mobile money connected all over the area. And then we will have also mobile to mobile, as well as machine-to-machine communications. Okay, so these are opportunities where we can think about business, how much the mobile business can be integrated into the game. This is a bit technical. I'm not going to analyze it, just a figure. This one presents more or less what will be the 5G architecture in the future. This is very useful for the operators or the system architects, the system engineers, where you can realize that we have somehow to transform the existing mobile infrastructure into the new 5G proposal, which is coming from ITU and 3GPP, as well as 5G PPP partnerships that they do propose about the architecture, about the new technology. So which are the network capabilities that we expect to have? We need to have data, more data coming through into the game, okay? We have a lot of connected devices, as well as we have a lot of opportunities over the internet. Which are the current technology improvement trends? Okay, which is what the operators expect and how they can build that. You see that from the network capabilities, we can have the current trends is, for example, network densification. What is the proposal to the current operators nowadays to be able to smoothly migrate to the 5G domain is, first of all, to build more sites. And when we speak about sites, we don't speak about macro sites, we speak about small sites, picocells. So the whole city infrastructure has to be filled up with a lot of small cells and picocells. A picocell and small cell is actually a cell which expands around a few meters or a few hundred meters, okay? So that we will be able to absorb the traffic from all these type of devices in order to be able to accommodate it over the cloud, presumably, okay? Which will be finally after that interpreted by the machine learning algorithms as well as the big data analysis. Okay, so we speak about some network densification. There are some other services, some other technologies which I'm not going to analyze right now, just for your view, like the carrier aggregation, which is there. We need advanced receivers. This is something new into the game. Advanced receivers means actually receivers that they will cooperate with MIMO and the massive MIMO technology. Okay, and speaking about the business agility, what we have to do is we have to have totally innovative technologies over the self-organized networks, the SON, which means that we are unable to optimize and to handle all this type of tremendous traffic and tremendous parameters that are going to be involved into the system. So we have to have special algorithms to be able to auto-configure the system as well as auto-optimize the system, as well as we speak about also the network slices, or if you like, we speak about big data analysis, where it's going to be part of the new core network infrastructure. So the operator needs to leverage the spectrum. Okay, this is something, of course, to be in cooperation with the country and with the government and the authorities that they do provide the spectrum abilities. They have to have a cost-effective, dense network, as I told you, the densification part. They have to coordinate the interference, because densificating the network will cause a lot of interference to the story. And this is something, this is the weak part of the densification. And if we can't handle this type of interference, if we can't mitigate that interference, we will not be able actually to have a very good network performance. Okay, we have to create common composite core. The core network should be agile, should be composite, and should be able to cover all previous technologies like 2G, 3G, 4G, as well as the new technology which is coming nowadays, which is the 5G. Of course, it's not standardized yet. We're still on the standardization process, but more or less we have some view what is expected in the first years of this technology. And finally, we have to have flexible functions and capabilities, okay, from the operator performance and operator maintenance parts of the operator network. Speaking of slices, what is needed is actually to have an agile core that will have a common software-defined boards, which minimizes the cost for the from the operator perspective. And then we have to build the network over this common hardware. Okay, having different slices over the common servers, we will have, as you realize, more domains, different actually operator domains into different slices. So having a unique infrastructure is easy for operational maintenance, cheaper from the board's point of view, and of course easier to implement into the network nowadays. And it's not so difficult to do it. All major operators and vendors nowadays, like Ericsson, Huawei, Nokia, and all the others that exist in the market, actually they do provide this type of slicing, and they do propose that slicing over the operator mobile technology. So this is an example where you can see that we have two separated networks, okay, on the left and on the right part. So different part of the networks, they come over the different radio parts, but they do converge over the common core, which means that we don't have to build separate cores, but we have a unified architecture for all different radio access technologies. As an example, you see, so we have different services that they are coming through the different slices, through the different radio parts, and they will end up into different slices over the common core. Okay. What is needed for that type of 5G domain? We need, as I told you before, the massive MIMO. Massive MIMO is a technology, if you can see on the left part of the slide, where we can have actually a lot of antennas, okay, together into one module, and these antennas will be able to define the azimuth as well as the elevation multi-lobe analysis over the antenna on the radiation pattern, which means that we can focus more on specific parts of the regions of the coverage area where we can improve the performance over the connection. So we speak about massive MIMO. We speak about millimeter wave applications, which means that we have to go on higher frequencies. Moving to higher frequencies, of course, has a lot of issues and troubles, but you realize that moving upper in the frequency, we can mitigate interference, and of course, we can have plenty of available spectrum into the market, and this is what you see over there. And the other nice story, speaking about the millimeter wave, is actually that we can combine the access and the backhaul together into one integration point. Meaning that in the past, in the previous technologies, like nowadays technologies, we have point-to-point connections, as you can see over there. Yeah, it's not working over the anyway, you can see the today existing technology of point-to-point communication. Tomorrow, what is going to be the integration is, if you go to the right part of the slide, we will have antennas that will be able to provide the point-to-point connection as well as the broadcasting connection. So both radio access as well as connectivity over a common aggregator will be part of one antenna and one technology. This is what we call access backhaul integration. And that will, as you realize, mitigate much the cost, the investment cost for the expansion of the networks, as well as it will be more agile over the applications. The densification means, as you see over there, that we have about 3 factors. One factor is the network density, which is the vertical part, meaning that we have to add more sites per square kilometer, and this is the small cells, as I told you. We need more spectrum, which is the x-axis, okay? More megahertz up to gigahertz spectrum available in order to be able to get more capacity. And then, speaking about the third part, we have to have better spectrum efficiency, meaning more bits per second, per hertz, per site. Okay, this is related mostly to new modulation schemes, the massive MIMO and so on. So if you combine all of them together, which is called densification, we end up into something which means more capacity, more throughput over the network. So we will be able to absorb in a few square kilometers a lot of traffic, speaking about gigabps or terabps. Okay, and this is what we call densification. This is what is the 5G finally. You can see actually the densification from the side point of view for the 3G, 4G, and on the 5G, what we expect is actually a lot of small sites. And all these small sites, they will be part of the city infrastructure, as you see on the bottom part of the slide. Okay. The other nice story about the 5G is that we just try to put everything into software. Of course, the radio parts, as it is the RF equipments, they can't be software because it is pure hardware, but all the functions behind, they will be over the software. So what we have nowadays is called DRAN, distributed RAN, where we have the sites, the hardware, and some connections over fibers or over, could be CPRI, which is a new standard. We can connect over some remote connections, remote hardware, like the remote radio components and the antennas, and we can spread the technology over the network. What is in the future is what we call CRAN. CRAN, which is the cloud RAN, means that all functions will be part of a cloud server. And what we need is actually a very fast connection, internet connection, or if you prefer, optical fiber connection, that will go straight to the small components, will be the radio components, okay? And all the hardware, all the interpretation, the intelligence will be part of the software which will be on the servers. This is called CRAN. And as you realize, we need a very efficient optical fiber network, more resilient with very low delays. Okay, and this is where we come with the CPRI connectivity, and we have fast fiber connections. We have to have the fiber infrastructure all over the city, otherwise it's not working like this. Although nowadays there are some vendors that they do provide also some short-range millimeter wave, microwave links, okay, exist nowadays, where they can promote your network expansion, but still, this is not resilient, as you realize, because microwave is not so resilient as it is the optical fiber. So what is recommended in the near future is to build a very, very high optical fiber infrastructure into the city. So these are the CRAN transport options that we can have. Of course, definitely we speak about dedicated fiber, as well as the optical transport networks. This is the highest priority, but then you can move also to the microwave part. Okay, as I told you, there are some vendors that do provide equipment in all these type of options. Okay, and yes, this is it. So, conclusively, I would like to tell you that what is the 5G? The 5G will not be something more different from the technology-wise from what we know nowadays on the 4G, on the LTE. But what is needed actually is to absorb tremendous amount of traffic. and we can't afford that over our own infrastructure nowadays. So what we have to do is we have to move to the radio parts, we have to densificate the radio, we have to make the core more agile as well as integrated into few slices, or if you like, some more cloud type technologies. And then we have to be able to interconnect the backhaul network with fibers with very, very low transport delays. And that will be the 5G for the beginning. And then we have the devices, which is the IoT part, or the business part, which will be the banking, for example, the IoT devices, whatever else you might think. That will be actually the application over that technology. Okay, thank you so much.